Okay, sir. A very good evening to one and all. The Center of Excellence in Safety Engineering and Analytics, CoE-SEA, welcomes all our dear participants to week 62 of the Weekend Talk on Safety Engineering Management and Analytics. The event is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. Today, we begin with this beautiful slogan, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amridam Gamaya, praying to Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Let me welcome our dignitaries on the virtual dais. We have Professor J. Maiti, the chairman of the center, Professor Obi Krishna, convener of the event, and we also have Professor B.G. Menon, who is the assistant professor of the Department of Industrial and Systems Engineering and joint faculty of CoE-SEA, and Ms. Mom Mitra, the expert speaker for the day. Ms. Mom Mitra is currently the safety manager of Industrial Byproducts Management Divisions across the locations in Tata Steel India operations. She has a master degree in organic chemistry from Ranchi University, holds a PG diploma in industrial safety from IEM Jamshedpur, and has completed MBA from XLRI in operations management and strategy. She is also a competent person for confined spaces certified by the Chief Inspector of Factories. She joined Tata Steel in electrical transmission and distribution as a technician, then moved to corporate safety, looking after training, workplace safety departments like hot strip mill, sinter plants, etc. She also worked in PPE research and development where major cost-saving initiatives like deproprietization and PPE mapping assignments were taken. She is also convener of SAFE, which works for propagating safety activities for school children, like conducting evacuation drills, training children on risk perception, road safety, and cyber safety. She is awarded by Ispat Suraksha Puraskar by JCSSI, Suman Sharma Award by Institute of Engineers India. She has also written 2 papers on positive isolation, tryout procedure in ICMIM 2021, and safety initiatives for injury-free major shutdown in sinter making plant in annual technical meet of IIM 2021. Ma'am, we are very privileged to have you today with us, and we are all very eager to attend to. Now, I kindly request Professor B.G. Menon to formally welcome our expert speaker.
Yes. So, a very good evening to you all. So, on behalf of CoE-SEA, we are really obliged to Ms. Mom Mitra from Tata Steel for agreeing between her busy schedule to deliver a lecture, a very valuable lecture on this 60-second weekend talk in SEMA. So, I wholeheartedly, on behalf of CoE-SEA, I welcome Ms. Mom Mitra to this expert talk on this weekend. Also, I welcome all of our valuable participants here to this 60-second weekend talk. So today, Mom Ma'am will be delivering a very valuable expert lecture on the topic PPE, holistic solutions as the last line of defense in industry. So I once again, on behalf of CoE-SEA, welcome you, ma'am, and all our participants. And ma'am, please, the dice is all yours. Thank you.
Thank you, sir. Thanks a lot. So, sir, I'm really grateful to IIT Kharagpur for giving industry practitioners like us a forum like this to share our experience and whatever we have learned in these few years of job. So, my voice is clear, sir?
Yes, very much clear, please.
I hope the screen is visible.
Yes, ma'am.
So, today we'll be deliberating on PPE as the holistic solution, as the last line of defense in industry. The flow of the presentation would be why PPE, why is it called the last line of defense, and Where is it placed in the hierarchy of control? We'll be seeing some global scenario, some statistics about PPE, and we'll be knowing the importance of PPE. And then comes the practice that we started to follow in our organization. That is the 3 rights of PPE management. How we use the 3 rights for developing PPE for many of the applications. So we'll be discussing 2 case studies in detail, and the rest I'll be sharing some glimpses of how these 3 rights were used for the correct PPE management. So the first case study will be development of high visibility FR garments. The second case study will be development of different categories of eyewear. We'll be summarizing the process of PPE development along with the 3 rights, and some of the good practices that can be horizontally deployed in many of the similar industries that in which we have reaped benefits. So why PPE? So let us look at some statistics. 84% of employees who sustain a head injury are not wearing head protection. If you see, 50% of the construction workers suffer a serious eye injury during their entire career. We know about NIHL, noise-induced hearing loss, a very common occupational disease in industry. So 99% of the noise-induced hearing loss is preventable if proper hearing protection is taken. Then comes one of the most serious type of injuries, which results due to PPE. That is 25% of all workplace accidents involve hands and fingers. And also 25% of all the reported disabling injuries involves foot injuries. And ladies and gentlemen, whatever statistics is being shown, this could have been avoided if the proper selection, if the shop floor worker uses the correct PPE for the job, these could have been avoided. We just discussed that 25% of the hand injuries. So you can see from this figure that the Bureau of Labor Statistics, it shows that the worldwide study, total injury to the upper limb, I mean below the shoulder, almost 47% is contributed by cuts. And if you see hands and fingers, it is about 25%. So here comes the importance of PPE in industries. But we should not forget that PPE is the last line of defense. If we see the hierarchy of control, we see elimination and substitution obviously at the top. So wherever there is a risk, there is a hazard, we should eliminate the exposure before it can occur. So that is the best way of saving the person. In case it is not feasible or not possible, we should use engineering controls. Which requires a physical change to the workplace. It may be barricading, it may be putting some mechanization. The third that should be used to reduce risk at workplace is administrative or workplace controls. So it may be SOP, standard operating procedures, the implementation of proper training procedures, but it requires the worker or employer to do something. Now from here, the human intervention starts. So we see that the effectiveness from here to reduce the risk starts decreasing. And of course, at the bottom of the triangle, you can see personal protective equipment, which always requires a worker to wear something. And of course, if you see the effectiveness, it is increasing when you go to the top of the triangle. And of course, when you come down, so we need more participation and supervision for reducing the risk properly at the shop floor. So we see the global scenario. They are taken from many of the OSHA data, National Safety Council, Bureau of Labor Statistics. So the data is quite disturbing. There are about 120,000 disabling head injuries on the job everywhere. And so it's over 300 a day. If you see, 90% of the occupational eye injuries could have been avoided with proper protective measures. If you see private industry employers, they report about 2.7 million non-fatal workplace injuries and illnesses in 2020. And the incidence rate of total recordable cases in private industry was about 2.7 cases per 100 full-time equivalent workers. 70% of the hand injuries were caused by workers not wearing the correct safety gloves. So we see that if PPE in its proper form is implemented, we will have better results. At least we'll have better figures than what I'm showing at the slide now. So here comes what we tried in our industry. And the motive of this presentation is what we should do as an industry practitioner for the best PPE management at shop floor, so that we can protect our employees from any of the injuries if any of the hierarchy of control fails. So the first right is right selection. So whenever we, I'll give you an example. Suppose we have the risk as exposure to molten metal spatters. The right selection, there may be many options. They may be aluminized garments. They may be fabric type of clothing. They may be asbestos-free safety curtain type of a thing. So what to select? Second is the right specification. After you come down to, after you funnel to a broad segment of the PPE, we should then decide what should be the right specifications of the PPE. So which standard should we follow? Should we follow EN? Should we follow NC? Should we follow IS standards? Should we follow what the vendor tells us? Should we follow what other industries are doing? And then, of course, when both things are done, then how to sustain the PPE? I mean, what should be the correct way of using and maintaining it so that it degrades in a slow space? It is more cost effective to the organization. So we tried this concept in our organization and we found good results in almost all the PPEs that we tried to develop. So when I say we are trying to develop, it's not manufacturing the PPE. It is just as an industry, when you have an ocean of products available in the market, how do you select the right PPE for your job, for your worker, so that your worker does not get injured? So I have my first case study, that is, we want to develop a PPE that will resolve the issue of visibility and maintain the same protection. The pics that you are seeing on the slide now are the employees of blast furnaces, steel melting shops, who were using these jeans jackets, the shop floor. Now there were many complaints with this jeans jacket. First of all, we had one LTI and 2 first aid cases, 1 lost time injury and 2 first aid cases 2 years back, where we saw that the jackets were getting burnt. So there may be many reasons. The reasons may be the jackets may not have been selected well. We do not know what is the specification of the jackets. How were they procured? Who approved the jackets? Somebody is using it for 5 years. Somebody may have been using it for only 6 months. So how many washes should the jacket sustain? So these are very relevant questions that has to be asked when a jacket like this fails and your worker gets burnt. So along with the quality issue, which is written in the third point here, there was a pertinent problem of the first point. That is, there was no visibility to the person working from a distance. We know that in an industry, it may not be very well illuminated at all the places. There may be places where persons are operating. Suppose there are crane maintenance, people are working at height. And the crane operator cannot see somebody who is wearing a gloomy jacket like this and he's working somewhere in the bottom, so he might hit the person. They may be, there were other category of electrical jobs. So in electrical jobs, this jacket was not allowed. They had to use some other jacket. But because the job was in blast furnaces or steel melting shop, the person had to carry 2 jackets. So these were very pertinent things which led to also the non-compliance of wearing the jackets. Why will a person carry 2 jackets on the shop floor? He will always try to carry 1 jacket. But the result of this was the increasing trend of the burn injuries, the LTIs, and the first aid cases. So we started trying the first right selection of the PPE. So what should the employees wear in applications of molten metal? Should he wear the aluminized garments? Should he wear FR aprons? FR is flame resistant. Or should he wear the jeans jacket only? Should we just try to improve the quality of the jeans jacket? What should we do? So the first right is looking for the job profile and exposure in the shop floor. So our case study involves shop floor employees who were in the regular inspection and maintenance activities in the shop floor, which was not a very high-end continuous exposure to spatters. So we freeze the some design like this jeans jacket, that we will go ahead with that. But for that, we need to understand what is flame resistant property. So flame resistant property is the property where this combustion is terminated after some extent. Whenever a material is exposed to flame, it will be terminated. And the material will self-extinguish whenever the source of flame is removed. And flame resistant fabric is, of course, the fabric which does not propagate flame when exposed to the source of fire. So the applications of the flame resistant fabrics may be either for the protection of people, things, or environment. They may be used in public places also, where if fire happens, it should not propagate. Or it also may be for personal protection, which was our case. It is not only for the firefighters, but also for the workers in various industries like metallurgy, ceramics, glass, aluminum, etc. So we try to understand the burning behavior of the flame resistant fabrics and non-flame resistant fabrics. So we can just to understand the burning behavior, we can see the flame resistant fabric here. So this is the start, and now the combustion starts. This is after 12 seconds, then after 24 seconds, then 40 seconds, and then after 80 seconds. So after 80 seconds, you can see that though it caught fire, but when the source of flame was removed, it was burnt a bit, but at least it did not propagate the fire. Fire was existing. And you can see the non-FR fabric, so what it could have done. And here again we come back that if a person is exposed to some molten metal or something, so what will happen if the fabric is not of proper standard? So types of flame resistant fabric. So it may be inherent, it may be chemically treated fabric. So inherent is the molecular structure of the fibers only are flame resistant. It is not treated. It is by inherent nature of the molecular structure. The fibers are injected with phosphorus, and then the fibers are weaved onto the fabric. So there are many types of inherent flame resistant fibers like aramid, modacrylic, polyester, FR viscose, and wools. If you see FR properties of inherent flame resistant fabric, so it is lifetime. So till the fabric does not tear up and goes to rags, the FR property will remain the same. I'm talking of the second right now. I'm going towards the specification. From the first right, I'm going towards the specification. So we tried to do all this research when we were developing this fabric, because we were trying to implement this fabric. Because merely buying a fabric and putting it on our workers will again put them to the danger of injury and the burn injuries, of course. And if it is burned due to slag or something, so it can the results can be catastrophic. Then we have the chemical treated flame resistant fabric. So chemical treated flame resistant fabrics are achieved by, of course, as the definition says, by chemical treatment, and usually in natural fibers. With we have an index called LOI, that is limit oxygen index, which should be less than 28. So it is the minimum concentration of oxygen that will support the combustion of the polymer. So it should not be greater than 28. And there are many additives which give the fabric this FR character. And the chemical treatment can be both, but yes, the difference between the inherent and chemically treated flame resistant fabric is that both can be durable to wash, 50 to 200 home laundry, depends on the treatment and depends on the treatment and the quality of application, the rigor of application that is there. And of course, it is non-durable. So some popular brands of chemicals used for flame resistant fabric are pyrobatics, CP-New, Proban, THPC. So these are some of the popular brands that were used for flame resistant fabric. So next we try to understand that how many types of fabrics were available. And next we try to understand that what are the universally accepted testing standards that we should look for. Because whenever we look for in the market, whenever an industry, a giant steel industry goes for procuring something, you have got a laundry list of so many garments. So what we should look for and where we should freeze it. So of course there is an ISO organization, we all know. There are European standards. They start with the word EN. There are American standards, NFPA, ASTM, AATCC. We have Indian standards that a product should meet for acceptance in the Indian market. Generally used protective clothing standards. We have so many European standards, right? So when we started researching on this, because on stake were 13,000 employees for whom this clothing was being fixed. When we started researching on these standards and started reading about these, we found that the European standards were the best suited. How I will tell you. So before freezing that, let us look on other basic properties of protective clothing that should also be taken into account when you develop a PPE. First is the comfort factor. We all know how a raincoat is uncomfortable if you wear it without rain for some time. So comfort factor is definitely is important. Wicking, that is when moisture evaporates from the skin. If you wear a fabric that has capillary action, so that is again uncomfortable. Air permeability, of course, we know higher permeability will lead to more comfort. Aesthetic value of the fabric, pilling. So we know the balls or pills formed on the fabric, that is not desirable at all. Abrasion. So if you are procuring something for a high risk job and the fabric is very prone to abrasion, so it is not again cost effective for your organization. Color fastness properties, washing, change in the color of the fabric, and we have seen that we'll be again seeing that how chemically treated fabric, the number of washes are quite less as compared to the inherent fabric. And of course, perspiration, changes in the color of the fabric, staining of the color while sweating. So these basic properties also had to be taken care of because the person is always exposed to a place which is at about 1500 degrees C in the industry. So protection had to be there, comfort had to be there. So as told earlier, we had started propagating on the jeans type of a jacket, which had three problems. One was that we had already LTIs and first aid cases. Second was that no visibility in the darkness. The person was not very visible to the crane operator and all. So there were many near misses related to this. And where it was very much the place was not illuminated, additional non-FR jacket had to be worn for visibility, which you can see in the third page, which was again an issue because this is a non-FR jacket, only worn for visibility. So if something falls on this, if the matter falls on this, it might lead to the pick that we saw earlier. That is, this may be totally burnt, which is a big risk, again to the worker. So the challenges were multifold now. So now we know what has to be enriched, at least this design has to be enriched. We knew the challenges, the three challenges that we have. And now we have the ocean of standards where we have to select what for the 13,000 employees in an organization. And the LTI and first aid cases were the biggest concern here. So as told earlier, we came to the right specifications of the PPE and we selected the standard after reading the standards, which had 6 parameters basically, where one of them was not applicable. So we have A1, A2, limited flame spread. We have B1, B2, B3, convective heat. We have radiant heat. And we know what are these for. These are for, again, to some extent, they lead to comfort factor. When a person is standing, how the heat radiates and how the heat is being conveyed to the inside the garment. The most important parameter for this was E1, E2, E3. That is the molten iron splashes. F1, F2, F3, the contact heat. So understanding the testing parameters, of course, of the garment helps in the proper selection of the garment and protects the wearer, which is our main aim of this development. Yeah. So when we were analyzing our composition of molten steel spatters with the line management, we saw most of the spatters fell in the left. I'm talking of the left side graph, between 101 to 160 grams. So if you see the adhesiveness of the molten metal spatters, so this is millisecond versus distance. So the box again shows the adhesiveness. That means if a person is there at 1 meter to 1.5 meter distance, the molten metal spatter will stick for 4 milliseconds in that case, to the fabric that is being worn. So when we tried to superimpose, we found that the box highlighted here is the most vulnerable part, which needs to be protected. It is 101 to 160 gram and 1 meter to 1.5 meter. So, and of course the time and the number of spatters. So based on this, we found that we should go for E3 because E3 is, if we keep the fabric, we'll be sharing a short video on this. If we keep the fabric at 75 degrees, and if we pour a molten metal of 60 gram, so this metal should slip down. It should not stick, it should not burn the fabric. E2 is 120 gram, E3 is 200 gram. So we found that it's better to go, because we see some of the spatters going beyond to 120 gram. To protect the person, E3 is the best suited specification for these FR jackets. So another problem was visibility. So this was our present jacket. We thought, can we put some fluorescent tape? But it could not resist the molten metal spatters because it's not FR, and FR doesn't, if it is FR also, it will not resist something of 1500 degrees C. We tried this, but a lot of glare. We tried combination of orange and blue, which was finally tried for this. So, well, I'll share a video. So, just to confirm the audio is, I have to share the audio. Just 1 second.
Okay.
Is the audio available? No.
Can you play it, ma'am?
Audio is there? No.
No, ma'am, no.
Just 1 second. How to share the audio? Forgot actually.
Ma'am, can you share once again? So in that sharing option, you will have the option
Yes,
of
yes. I remember. I remember. Just confirm if the audio is there.
612, it is the standard where the behavior of fireproof materials in ISO 11612, it is the standard where the behavior of fireproof materials in front of heat and flame is checked. Limited flame spread. Heat resistance at a temperature of 180 degrees Celsius. Contact heat. Radiant heat. Convective heat. Limited flame spread. The materials and seams shall be tested according to Procedure A, A1 code, or Procedure B, A2 code. When tested according to Procedure A, the flame is applied horizontally to the fabric. It shall meet the following requirements. No specimen shall have hole formations. No specimen shall flame at the top or on either side. No specimen shall melt or have flaming or molten debris. The mean value of after flame time shall be less than or equal to 2 seconds. The mean value of afterglow time shall be less than or equal to 2 seconds. Seams shall continue to hold the panels of fabric together. When tested according to Procedure B, the flame is applied at a 30-degree angle to the fabric. It shall meet the following requirements. No specimen shall flame at the top or on either side. No specimen shall melt or have flaming or molten debris. The mean value of after flame time shall be no less than or equal to 2 seconds. The mean value of afterglow time shall be no less than or equal to 2 seconds. Heat resistance at a temperature of 180 degrees Celsius. All fabrics and hardware used in the garment and/or clothing assembly shall not ignite or melt and shall not shrink more than 5%. Sample size is 50 centimeters by 50 centimeters. The test time is 5 minutes. An optional test at a temperature of 260 degrees Celsius can be done as well. Contact heat. The fabric specimen is placed over a heated metal cylinder at 250 degrees Celsius. On the other side of the fabric, there is a calorimeter that measures the temperature rise. The time of the calorimeter to increase 10 degrees Celsius is calculated. Radiant heat. For each material or set of materials, at least 3 specimens shall be tested. 230 millimeters by 70 millimeters. Test method. The specimen is subjected to an incident heat flux of radiant heat of 20 to 40 kilowatt per square meter. The heat passing through the sample is measured using a calorimeter placed behind the fabric and in contact therewith. The heat radiation will stop when the temperature rise of the calorimeter reaches 10 degrees Kelvin or after 5 minutes. It will be measured the time needed in seconds to produce temperature rise of the calorimeter, which is the time required before a person starts to feel pain from second-degree burns caused by radiant heat. Convective heat. For each material or set of materials, at least 3 specimens shall be tested with size of 140 millimeters by 140 millimeters. Test method. The specimen is subjected to a heat flux of 80 kilowatts per square meter. The heat passing through the sample is measured using a calorimeter placed above the fabric and in contact therewith. It will be measured the time needed in seconds to produce a temperature rise of the calorimeter of 24 degrees Celsius. The specimens of multi-layer assemblies must correspond with the usual order of the layers.
So this is how the EN11612 specs are what I was explaining now. So am I muted? No, it's okay. So this is how the EN11612 specs that I was explaining are tested in a factory, and that is how a standard supplier puts a mark on it. But as an industry, we need to understand that what we spoke here and what we decided here, because whenever a supplier comes, he might tell you E2 also. You might see garments with E1 also. So as an industry, you may go for a cost-effective option. But if you want zero harm of your workers, you need to know the right specification of the PPE that is being procured for your people. So now was the question of design of garment along with trial. So we had a workshop, and we tried to design something, and based on trial so that it doesn't cause glare also, we decided to go for this. After it was done, of course, there was a circular for deployment in shop floor by the senior management. There were internal communication forms and all. Also, you must have seen, I was mentioning in the earlier slides that in electrical applications who are there in blast furnaces, they have to carry 2 jackets. One is the arc flash jackets that is used in electrical applications, and another is this FR jacket. So now we tried exploring inclusion of this ATPV value, arc thermal protective value, into this jacket. So once this was done, so this was the single point solution for all the applications of blast furnaces and steel melting shops. The third right, that is the right usage of maintenance. So if you remember the first slide, what we saw, the jeans jackets, nobody knew. Somebody was using it for 5 years, somebody for 2 years, somebody for 6 months. Somebody, the contract workers who did not know and who are normally, they use it till it gets to rags. So they were using for maybe 5-6 years when it was completely faded, and so we are exposing those people to high risk. So now there was a guideline that, because we know that chemically treated FR is 50 washes. So it was like if you wash it once a week, it's 12 months, covers it. And so, the guideline was there by the senior management, and it used to be monitored. And so people knew that how many times should I wash. And I'll show in the subsequent slides, not just a guideline, we had a program called Apne Dost Ko Pehchano, which told about many of the PPEs, how to use them, how to don them. So again, let us reiterate the right selection. We selected the FR jackets as PPE for this kind of job. Of course, we have aluminized garments and all, but for inspection and maintenance from a distance of about 2 meters, use FR jackets at PPEs. We tried this right specification where we stressed upon this E3 because, and to sustain this E3, to keep a check on the suppliers, we also started this third-party testing schedule from external labs. And we started having random samples and quarterly checks for the C3 testing especially. And we have right usage and maintenance. So after 50 washes to be doffed, to be discarded, it fades. All buttons and velcros to be put on shop floor. So this is actually I tried to put this MSc into a simple slide, the process of PPE development. So the process is we have request or concern from the users. So whenever we have this request or concern from the users, we try to have a product development workshop, inviting all the product probable suppliers along with the line managers. The line managers were from the specific departments where the concerns came from, and also from the similar departments who were indulging the same application. We did the comparative study of the specifications vendor-wise, because there's not only one supplier, there may be many suppliers who were supplying this. And then freezing the technical specs, the second right, and proposal of the vendor panel. Then trial with users by samples provided by the vendor. Then feedback from users. And these are all ISO documents, so in a very specific format. Feedback about the quality, the comfort, the fit, the quality of stitching, the buttons, the accessories. In case of respirators, there was some other feedback form. So there were many feedback forms made out of this. Then if the feedback was okay, otherwise it again went off into a PDCA. But if the feedback was okay, again the proposal in Apex approval committee was made, which consists of members of procurement, safety, and line management. So once the Apex approval committee, based on the feedback, if the committee felt that adequate number of trials were taken, the feedback was done, feedback was okay. So the process of procurement now initiated. So communication of procurement details to users now, but it may be a rate contract or whatever the details were there. And of course, the third right, communication of do's, don'ts, tips on maintenance to users. So when we follow this entire cycle, we have seen in almost all of the PPEs that we have used that the PPE development is holistic, and at least there is zero harm. Of course, comfort may not be to the extreme, but it was the best possible. But at least from protection wise, we were quite sure that the user is very happy with the quality of protection this was offering. So some of the roles and responsibilities. So if you see the line manager is the departmental person who's in charge of all the work. He should select and ensure that employees using, including contract employees, use the appropriate PPE. This will ensure that PPE fits and it correctly is used by the employees. Compliance should be there. Display should be there. Of course, other hierarchy of control should be continuously explored, because PPE is the last line of defense. And we should try that if other hierarchy of controls is there for the mitigation of risk, then we should avoid using this only for the worker. Ensure that a system of feedback and reporting is there, very important. Otherwise, we'll not be able to know the OFIs of the current PPE. And of course, in high-risk jobs like a steel industry, people will get injured. Ensure that PPEs are recorded in online issue system. So for this feedback, we had this online issue system also. What should the contractors do? Because we have a severe attrition rate like other industries also. So they should provide and ensure that their employees use PPE, which is specified by the organizations and is certified by. So there was a specific list, and the contractors for the high-risk jobs were given the same PPE by the department. Wherever they used to procure, they were given the specification and the probable vendor panel so that they can buy that. PPE fit is very important. Of course, like in case of respirators and hand gloves especially, PPE fit is one of the most important criteria. And we should ensure that all the PPE should be of good mechanical construction, sound material, and of course, conforming to proper standards. What should the employees of the organization do? So of course, compliance should be utmost priority for them. They must use all applicable PPE that is in there for the shop floor. and also give correct feedback about PPE related to this hazard protection and comfort. We'll go to the next case study, that is development of the PPE that will cater to different applications of eye protection in industry. So again, we know that we are going for a PPE that will cater to about 40,000 workers, and we need to select the best for them. And there is an industry, there is a, again, ocean of vendors who can give you CR39. They will tell you this is very cost effective. They can give you polycarbonate. They can give you something else. So what to select? So let us understand, a bit disturbing slide, but what are the primary reasons for eye injuries? There may be projectiles, splashes, airborne substances, dose to the eye, radiation. So what is the first right now? So if it is a splash, it should be a visor. If it is a goggles, if it is a daily wear kind of a thing for inspection maintenance, it should be a goggles. If it is a chemical unit where chances of splashes may be there on the face, it should be a visor along with this swimmer type of a goggles. I have not used the word panorama goggles. I've used swimmer goggles just to indicate that the tight fit goggles that should be there. It depends on the exposure and the amount of risk that the person is exposed to. So what are the selection criteria then? Now we know that, so nature of task, of course, the design, the comfort, the shape, size, coatings. Coatings is very important. Suppose like in a hot and humid industry, like in climate that we have in India, a lot of sweating happens. So if your goggles is not anti-fog, so what will happen that after 2 or 3 minutes, fog coating will be there on the goggle. And the person who is wearing, he'll be so uncomfortable, he'll tend to remove the goggle again and again. So if the coating is not right, the compliance will be poor. So a very, very important part in the selection criteria. If you see in underground mines, very humid, very humid. So if you don't put a very strong anti-fog coating or a permanent anti-fog coating, so a person will never wear that goggles. So he is bound to remove that goggle. So it's very important to select a correct PPE according to the nature of task that you are there. Cleaning, of course, and there are special cases. So standards we have spoken a lot. So again, we see in eyewear, we have IS, we have EN, we have NC. So what to go for? So the second right. Can it be glass? Normally we wear glass, and at home, in our normal powered goggles, we have glass. We have plastic, we have polycarbonate, and we have something called CR39 that was also very much heard. But when we were seeing the impact resistance, right? So you can see the glass breakage occurred at 60 mph. Plastic, it occurred at 136 mph. Polycarbonate sustained a long distance. When a 1/4 inch steel ball traveled in excess of 340 mph, it did not break through the dural light lines. So let us see some of the videos of ANSI Variant 7.
This test is intended to determine.
Is the sound audible, Swin? Can you confirm?
It's not audible, I think.
Yes, sir.
This test is intended to determine the
Yes,
capability
it is
of the
audible.
protector to resist impact from high-velocity, low-mass projectiles. The spectacle frames must be capable of resisting an impact from a 1/4 inch diameter steel ball traveling at a velocity of 150 feet per second or 102 miles per hour. No contact with the eye of the head form is permitted as a result of impact. The frames must remain intact and the lenses must be retained in the frames. This is the damage caused to a polycarbonate lens. Now here's the same test using a safety spectacle with a CR39 lens. And now the results using safety glass lenses.
So this is the impact test according to Z87. Now you see the dust test.
This test is intended to determine the capability of goggles to keep large dust particles from reaching the wearer's eyes. Cotton lint covered with blotting paper soaked in water is placed between the head form and the goggles. The head form is then placed in a dust chamber where coal dust is circulated with a blower for 60 seconds. After 30 minutes, the head form is removed from the chamber. The goggles are then removed from the head form and the blotting paper is measured for possible leakage. To pass this test, the paper must be at least 80% clear of the original reflection.
And this is the high mass impact test.
The capability of spectacle frames to resist an impact from relatively heavy, pointed objects traveling at low velocity. A pointed projectile weighing 500 grams is dropped from a height of 50 inches onto the lens. To pass this test, no pieces can become detached from the inner surface of the frames, and the test lens must remain retained in the frame. This is the damage caused to a polycarbonate lens. Here's the result of the same test with a CR39 lens.
So we saw how NC-Z87 suited our applications of high velocity impact, high mass impact, and of course high dust exposure. So finally, this was the testing setup. And finally, we went for the specification of Z87.1. So there were many eyewear developed after this exercise. We had general purpose safety goggles. We have over prescription glasses. We had panorama goggles. We had also prescription glasses, that is polycarbonate, that is powered prescription glasses. So like in over prescription goggles, you have to wear your own specs and then this over prescription goggles. But what am I trying to say is we have powered polycarbonate glasses where you have to wear only one glass. Third, right, of course, polycarbonate is very, very vulnerable to abrasion. So if we directly start cleaning with a, it will be glass will be damaged very soon. We need to clean the lens under running water and then wipe it. So some of the good practices that we tried for horizontal deployment in other industries can be. We started releasing templates of Know Your PPE every month for the common user after every development. So these are some of the samples, like in polycarbonate lens and frame. So what do we have? How do you care and maintain it? We started with two types of shoes. One was the normal safety shoe with steel toe in the shop floor. Another was people who work in oven top cast houses where the surface itself is quite hot. So for that, we started using this full grain leather impact resistance of 200 joule. And the most important differentiating factor from the normal shoe was this nitrile rubber sole, with a temperature, withstanding temperature of 300 degree for 1 minute. So this is commonly used, and if you see, the heel part is quite elevated from the normal shoe, just to save from the ingress of any spatters that comes in, because person will be going near those applications for inspection and all. So the person should know that when you have a large employee base and a large contract employee base, so people should know that what all have been developed and for what reason. So this template used to be released regularly per month, and also whenever some changes used to happen and how the procurement will be done, that used to be mentioned. We started working on hand gloves. So hand gloves are not covered in this case study, but there are 14 types of hand gloves that we tried to develop. So you can see in this pic, there was this brick cutting activity. Though this was trying to be, they were trying to mechanize, but sometimes they had to cut some non-regular size of brick with this. And this brick cutting activity, because the hand is in very close vicinity of the moving blade. So we started this butcher's hand gloves, high cut application, that if finger sometimes in any case comes in touch also, so it will act as a last line of defense. We started with leather leg guards because we saw that when a person goes very near, in some cases, to molten metal, so sometimes or some in the welding applications, the spatters have entered inside the shoe and have caused burn injury. We started this leather leg guards, which were lined with FR cotton and all. Chemical resistant hand gloves. So this is all for the user to know that what is this PPE for, how to procure it, and how to use it properly, so that it is both ways. It is cost effective to the organization also, and it is of the proper fit and comfort to the user also. We developed 4 kinds of respirators: the dust mist respirators, the organic vapor respirators. So this was again a challenge. Now people should understand what to wear where. If they're working in a chemical lab, acid vapor. If they're working in coke ovens, they should go for organic vapor. They're working if they're going for a normal line walk and normal job, they should go for a dust and mist. So they should know this. So, and how to use it, that is the most important, how to wear it and how to tighten the nose clip, so that we saw the dust test there. So it also passes the dust test, but it has to be properly worn. We developed welder garments in the similar fashion of FR garments, but this was specifically for welders. We started, as I discussed, initially we had about 200 categories of hand gloves in our organization. We started consolidating them, seeing the specifications, and finally we freezed about 14 types of hand gloves. You can see high puncture resistant hand gloves, for high abrasion hand gloves, and for handling grease and oil, where there were chances of slippage things, adhesive handling, metal mesh. We started, so first was releasing the template. Second was process of capturing the feedback from the users that I mentioned somewhere. So we had an online system. We have an online system where anybody can enter the feedback, that is it okay, is it good, even complaints of stitching and buttons and all. So it was a journey of continuous improvement through this. And every monthly we used to review it and resolve the issues. Of course, PPE for customized applications, we know that high heat exposure, the comfort part had to be taken care of. So we again developed in the same line of 3 rights, where we have this small capillaries of water line, and which were used when person was sitting in front of the mold. We tried some backpacks, and this was certified by OHS and the medical doctors also, because we were worried about hypothermia. So person were very comfortable using this and doing job for a longer period. So we can see lime kilns, blast furnace, mud gun. We tried some of the customized PPE, like we tried color coding of the safety helmets, green for the. So this is just change of color. We wanted the rail crew who are working on the loco and the wagons to have a different color jackets. So we tried something called the rail crew jackets, that is being used. So anybody who is working on the railway line must wear this jacket because it is a differentiator that this person is a rail crew staff, not an unauthorized person who has gone into the loco area. This is one of the most important for the third right, that is apne dost ko pehchano. We started. So started for many things. We started for the helmets, how to use it, how to change the chin strap, how to change the inner part. Then if the first impact is there, you have to discard it. Eye protection, and many of the other do's and don'ts. We started educating people on the hearing protection also, that what to wear and how to wear, how to use the earplugs. Because normally people put it and try to push it inside the ear. So how to roll it and put it into the ear canal and then release it. It will take the shape of the ear canal. And how to don off it. Foot protection, of course, they should know what shoe should I wear in which area. Respiratory protection, one of the most important things. And why is it important? So this is a very short program we used to do about half an hour in the shop floor to tell people that the compliance increased. The foreign body in eye cases that were in the first aid were in the initial years, it was about every month we had about 15 to 20 eye penetration cases of foreign body. That reduced to 0. Until date it is 0. So the compliance was so good. Respiratory protection, how to use it. Right? So how to use it, how to put the nose pin, where should be the first strap, where should be the second. Now COVID has taught us this very nicely, but this was pre-COVID. And of course, when you are working in confined spaces, so what to wear, supplied airline respirator or powered air purifying respirator, what to wear here, at what place. So finally, this is the last slide of my presentation. Finally, we are committed to zero harm, and all industries are. Nobody wants to die, nobody wants to get hurt. And PPE is the last line of defense. If we abide by it, it definitely gives results. But as an industry practitioner, we must know what to select, what to procure properly for our own employee, for our contract employees, so that they remain safe while working in our organization. So thanks a lot, sir. That's all from my side.
Thank you, ma'am. Thank you, ma'am, for this informative lecture. Now, sir, ma'am, we have received several questions in the chat box. So I am taking one by one, ma'am. First question is, ma'am, due to high temperature and humidity, persons are receiving genuine complaint about discomfortness while using full body chemical suit, even for 30 minutes only. So is there any solution available which can reduce this kind of discomfortness?
See, first of all, a disclaimer, I will answer all this question out of my experience of 4 years in PPE research and development and what I've seen and what I've read. So, see, the same problem we had, I can recall 2 areas what is being talked about. So, number one is for comfort, there is a specification. Okay, so I'm forgetting that there is the EN specification for comfort starting with 3. I don't remember. I don't know, 318 or something. So that you can look for, number one. Number two is that we must look for, we can give them some extra comfort. Extra comfort is we can give them a ventilation hood from behind, or I was showing that cooling vest. So something like this can be also explored, where it goes inside the suit. The person is sitting, or the backpack that I was showing. That may be explored.
Thank you, ma'am. Now, ma'am, next question is, in case of electrical flash from the breaker, what is facial PPE being used as body is already protected from the fire retardant garment?
there is a hood which comes along with it. There is a hood, and that is a mandatory thing that has got an ATPV, Art Thermal Protective Value. And the hood is, I mean, it's not only the jacket, it's the complete set of the hood, the shoes, and the body part, the jacket. So
Yes.
the hood is also there, and it is available with standard suppliers with standard specifications.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Along with the visor, visor is also arc proof.
Yes. Now, ma'am, sir, next question is how is color coding of PPE is decided?
Color coding of PPE has also got a EN standard. If you see the visibility, why is orange used? So orange is of course used because orange is BIBGYOR. So O is one of the second best good reflective thing that is visible from a distance. And there is a standard for EN, I think 351 for reflectiveness, where orange is best suited. So that is there. But if you talk of helmets and all, that is the benchmarking from various industries. Normally green is orange, I mean, safety professionals use green, firefighters use red. And for employees, many companies use white, we use blue. So there's no standard benchmarking as far as I know.
Yes, ma'am. Yes, ma'am. Then, ma'am, the next question is generally Indian regulation mandates industries to use only Indian standard approved PPE, but there are very few Indian standards available, and the testing agencies are also not available. For example, cut resistant gloves. Yes, ma'am.
I would like to differ. A very good question, but I would like to differ a bit because I've seen many industries who only go for EN standards. There is a mix of standards. Like in shoes, we go for IS. We have gone for IS in shoes and helmet because they are equivalent to EN standards. But if we talk of FR, so we find that EN is far better than IS in that case. So what we try to look as from the industry point of view is that we should look for the best suitable specs for the shop floor, and that should be cost effective in terms of the right usage and maintenance, not from the right protection point of view. So what the question was asked was IS. I don't know there is a mandate or not because I've seen many steel industries who use EN and NC. EN is European standard, sir, and NC is American standards. IS is Indian standards. So there's no mandate that you cannot use EN or NC. That is for sure. And the second part, that is their external testing authorities are there in India, and they are government certified labs because we have used them for our external testing, third party testing.
Yes, ma'am. Ma'am, the next question is why should we call PPE the last line of defense instead of it is the first line of defense to the worker?
We call it last line of defense because if you see the Swiss model, I mean, if everything goes wrong, finally it will save you. If there is no if elimination doesn't work, if substitution doesn't work, engineering control fails at times, so it will save you at any cost. So it is hence called the last line of defense.
Yes,
But
ma'am.
of course, it is the mandatory thing to be done. The word last doesn't demean it. It is one of the most important component, and of course, it is the bare minimum to go to the shop floor, and we should walk the talk wearing all the PPE.
Yes. Thank you, ma'am. Now I would like to invite Professor Menon to provide vote of thanks to our expert speaker. Over to you, sir.
Yeah. Am I audible, Shobik?
Yes, sir. Yes, sir. Audible, sir.
All right. Okay. So On behalf of CoE-SEA, I extend my sincere thanks to Ms. Momitra for delivering a very interesting and very important lecture on this topic of PPEs, which is I felt very interesting to me actually, because I have never thought about this facet of safety engineering at all. Maybe not from a research point of view, but mainly I was thinking about their usage in the shop floor and so on. So this has given me some very interesting insights to the importance of such things to be utilized under shop floors, especially towards maintaining safety. So thank you very much, ma'am. And I also extend my sincere thanks to all the valuable participants. And I'm sure that they have received some very interesting information and knowledge out of this uh, expert lecture. So once again, I thank Ms. Momitra and all the participants for today's lecture. So thank you very much, ma'am, and thank you very much, one and all. Thank you. Have a nice day.
Thank you, sir. Honored to be a part of this forum. Thanks, sir.
Thank you very
Thank
much.
you, sir. Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you, sir.